guys, let's understand the entire process of a galvanic cell. Okay, if I can say it to you and you can explain it to someone else, then it means you understand how a galvanic cell operates. Number one, a cell cannot operate if it doesn't have standard conditions. Okay, that is the first thing that you need to look at, that it has met all the requirements of a standard solution, or standard conditions. Okay, number one, a temperature must be 25 degrees Celsius, all right, or 298 Kelvin. Number two, the pressure must be exactly 101.3 kPa, meaning kilopascals, and then the concentration is 1 mole per cubic decimeter. So those are the three main standard conditions for any cell to operate. Please take note of that. Right, as soon as I've observed that, okay, this is going to happen in a standard condition, and then I'm going to look at what we call the zinc half cell, because remember, you would have two electrodes, right? Because there's two beakers, meaning you'll have two electrodes. We have the zinc side and you also have the copper side. Now, I want us to first look at what happens on the zinc side. Okay, number one, according to the table of reduction potential, zinc is found at the top and then copper will be found at the bottom. I want you to check your table of reduction potentials. You will see what I'm talking about. Zinc is found at the top and then copper is found at the bottom. Now, because of that, okay, then zinc has a high reducing ability. Okay, because of that, zinc has high reducing ability. Now, copper has high oxidizing ability. Okay, that is the first thing that I look at. Now, because zinc has high reducing ability, it means zinc will undergo oxidation. Zinc will undergo oxidation. Okay, now remember what we talked about, guys. Oxidation is a process where we are losing electrons. So meaning on the zinc side, I am going to lose electrons. Is that clear, guys? Now, when I lose electrons, electrons are going to move out through the connecting wire. Do you remember there's a connecting wire? Through the connecting wire, and then to the voltmeter, and then it goes to the side of the copper. But I'm only interested in zinc. What happens in zinc now? Number one, I'm aware that there's oxidation, and I'm aware that there's loss of electrons, meaning electrons are moving out from that side. Is that clear? Now, because electrons are moving out from the zinc side, then it makes that side to be more negative because I am following the direction of electrons. Is that clear, guys? So the side where an electrode, if you can remember, the electrode where oxidation takes place is called an anode. Okay, so because electrons are moving out and we are saying that that side becomes negative as a result of electrons, it means the anode is going to be negative. Is that clear? That's the second thing that we take note of. Now, what's going to happen as soon as electrons are still going out from the zinc metal? As electrons are going out, guys, we are going to observe, number one, the metal or the electrode corroding. Okay, it's going to corrode, I mean it's going to rust. Why does it rust? It rusts because, remember, originally it would have had equal number of protons and electrons, but now it doesn't have the equal number of protons and electrons because electrons are going out. So meaning we are left with the cations, which are the zinc ions, the Zn2 plus. Okay, now this Zn2 plus from the electrode, because it's highly concentrated, it is then going to move into the solution, guys. Okay, it's going to move into the solution. I'm going to start afresh. I said to you, number one, we have oxidation, meaning there's loss of electrons. Electrons are moving out into the connecting wire. Now, because that side we have more electrons that are going out, and then we get a situation where the anode is negative. Remember, anode is an electrode where oxidation takes place. Sharp, okay? Now, every time when an electron is being removed, we have a zinc ion that is going into the solution, right? Now, if this continues, guys, we get to a situation where when we observe, now this electrode is going to corrode or it's going to rust, okay, if you may like. And then number two, we observe that now there's going to be a high concentration of Zn2 plus in the solution. Remember, that solution would have positive and negative, but as soon as you get positive and positive and positive going into the solution, you're going to get to a situation where unfortunately the positive ions are going to dominate. Is that clear, guys? So the negative ions are going to be used up quickly. We will have Zn2 plus that is dominating in the solution. Is that clear, guys? Right. Now, as these electrons are moving out, obviously, that's when we are going to get a deflection on the voltmeter. Now, because of that process happening, we start chemically inside the beaker and electrons are going out to the voltmeter. Then we see that there's some sort of energy conversion there. From where? From the chemical energy to electrical. Do you see that, guys? I said electrons are going to move out, so they move out from the electrode, but everything starts in the beaker. There's a chemical reaction which is now going to produce chemical energy, and then it's converted to electrical energy, because we now start to observe the voltmeter having a deflection. On the copper side, remember, electrons have moved from zinc to the copper side. So meaning they've passed through the voltmeter or the galvanometer, then to the copper side. So electrons are moving to the copper electrode, right? Now, in the copper electrode, I want you to understand, as soon as I'm receiving electrons, if you can remember, we said when you gain electrons, you are being reduced, right? So meaning, because electrons are attracted to the copper side, then it makes the copper side to be more positive, guys. I want you to understand. The anode is from the zinc side, right? Because electrons are going out from that side, and then the anode becomes negative, meaning the cathode, which is where the reduction takes place, would be the positive side. So my cathode is positive. Is that clear, guys? Especially when we talk about the galvanic cell. Now, these electrons are now coming in and coming in and coming in and coming in. Obviously, there's something that I'm going to observe. Number one, this copper electrode, because it's receiving these electrons, we say number one, it undergoes reduction. And as you receive and receive these electrons, what's going to happen? Then you're going to increase in mass. Okay, that's what we are going to observe. The copper electrode is going to increase in mass, meaning it will have a high concentration of electrons that are surrounding the copper electrode. Now, as a result of that, the copper ions, which is the Cu2 plus ions that are in the solution, because remember, if we have a copper electrode, it also means that the solution must be a copper solution. So the copper 2 plus that is in the solution will then be attracted to the electrode. Okay, as a result of what? Of electrons, because positive is attracted to a negative. So when this Cu2 plus is attracted to the electrode, what happens, guys? Think about it. The Cu2 plus is 2 plus, and then as soon as you gain electrons, you are being reduced. What are you being reduced to? You are being reduced to 0, meaning you become more neutral as you are attracted to the electrode. So at this stage, we have more of copper on the copper electrode. Hence, the mass of the copper increases. I want you to understand. Now, because the Cu2 plus keeps on moving out of the solution, we have a problem. It means now in the solution, we will have high concentration of the N ions, meaning the negative ions, okay, they are going to be left in the solution. On the zinc side, we have the Zn2 plus that is getting into the solution. As a result, it dominates. On the copper side, we have more of negative ions that are dominating. Do you get what is happening here? So automatically that tells you that we are going to have a problem, guys. That tells you that we have a problem. Now, what would be the solution to this problem? The solution to this problem is the salt bridge. That is why we have a salt bridge. In most cases, a salt bridge is made up of a salt solution, and obviously a salt solution will have a positive and a negative ion. Now think about it. If I add a salt bridge to a problem that I've created now, because on the zinc side, I have more positive ions, and then on the copper side, I have more negative ions. What's going to happen? Now, as soon as I add the salt bridge, what is the function of the salt bridge? Is to complete the circuit, okay? Or to maintain electrical neutrality. You're completing the circuit, or you're maintaining the electrical neutrality, meaning on the side where we have positive that is dominating, then there's going to be a negative ion that's going to go in that solution to neutralize the positive that is dominant on the zinc side. On the other side, we have negative ions, so meaning a positive ion will move from the salt bridge into the solution where we have a negative ions to do what? To neutralize the negative. So basically, what I've discussed now, it is the entire process that goes on in a galvanic cell. If you can be able to remember that, guys, I am telling you, then it's easier. It's going to be easier to figure out what's going on. Okay? Guys, please subscribe, and please just ask a lot of questions that you need clarity on. I will be readily available to answer those questions.